Hello, everyone. I'm Rita Campos from EXIGENCE, the coordinator of EXIGENCE, another one of the projects in the stream of architecture. So I guess not all of you have used one of these. I have, but maybe not the younger part of the audience, but most of us use something like these, which is something that we carry all around to do increasingly more and more things at the tip of our hands. So there has been this ongoing digitalization that we have been experiencing all over in all domains in the society at large, in conjunction with recent ICT trends, has transformed the way we live and the way we operate and work. And this has increased also the technical realities of the telecommunication landscape and what we do, and has increased energy consumption and also emissions, which is no longer acceptable and not aligned with the sustainability that we want to see. So that is where we want to play a role as Project EXIGENCE. So the mission of the project is to integrate measurement, optimization, and incentivization to contribute to reduce the energy consumption and emissions of ICT services, which are used in all of the domains that we can think of, and that are provided by expected future ICT ecosystems, which is a very large area, right? So the project always focuses or always works around these three pillars: measuring so that we know what we are talking about, then optimize in the sense of making the best use of resources, and then incentivize, because we do believe that will be the best way or one of the fastest way to achieve some of the results. Considering the objectives of the project, so I'll talk about the three main objectives that we want to achieve in the 30 months of the project that started in January, like the others. So we want to design and implement a system that can reliably assess the energy consumption and also the carbon footprint of the use phase of the ICT services. And I will get into a little bit more detail. And then we want to explore and adapt some incentive compatible energy consumption and carbon footprint mechanisms. So trying to understand how we can influence these reduction. And the third, we want to gather all the insights from our work in the previous two objectives and feed them into standardization or into requirements for suitable solutions as much as possible. For a more sustainable outcome of our project as well. These will be measured by three main key performance indicators that we want to impact in our project, which is trying to reduce energy consumption and carbon footprint by a factor of 3 in relatively simple use cases, for example, video streaming. We want to reduce energy consumption and carbon footprint by a factor of 5 in some use cases with strict guarantees. And then we want to try to bring CO2 emissions to 0 or as much as possible in some realistic deployment options for some of the use cases that we will be considering in our project. So what is our technical approach? So starting from the main observation that has kind of been our motivation, so we can all relate or try to understand that it's very different to observe a standalone device and the energy consumption and CO2 emissions posture of a standalone device that mainly depends on how the device was manufactured and how it works, and trying to understand the energy position or consumption and emissions of a connected device that is connected to remote services and interacts with several others. So understanding or being able to assess the use phase of services impacts the consumption of the device itself. So there's a high risk for wrong conclusions if we're looking just at the device and not considering what's around the device or what it is connected. So the use phase measurements of these energy posture of running ICT services are required to understand exactly what is going on. So we need to and require measurements at the service level, not necessarily at the device level in a standalone perspective. So this is where we wanna act. So we want to have these measured echo data of energy consumption and emissions as a standard 6G feature. So fast forwarding in time, our ideal situation would be, as you see in these mock-up, that for connected devices, you would have this little information next to your network connection or Wi-Fi connection on top of your phone of what you are consuming in terms of energy or even emitting in emissions. So these for these connected devices, which are the devices that we all use connected to a lot of different services, these green labels must account for the remote part of the service realization. And these, as you can imagine, the value chains are very different and very flexible and very agile. So in a cross-domain, for example, figuring out an energy saving solution would require to trace measurement data gathered by different parties and then have the technical means to act on these different domains, resources, and subservices because they are just different. So again, we would be talking about measuring, optimizing, but then trying to incentivize and involving the several stakeholders that are manufacturing the devices, providing the services, using, and so on. So coming back to our three-pillar approach, again, measure, optimize, and incentivize. So we want to enable eco-data measurements at the service level, not domain level. So that would be in the first pillar of measuring. Then we want to optimize the resource footprint in terms of energy and emissions per domain base. And then we want to incentivize, so enable all players to be able to redeem non-expenditures on the carbon market so that they really have an incentive to contribute to this reduction and to the previous two pillars and to the measurement as well. What do we need in order to live this as a reality? So what do we need as required technological capabilities to be able to assess the sustainability at the service level? So in a global perspective, we need common ICT service level metrics. And these we're also indicating here our potential insights or potential collaboration and connection to standardization bodies, so to ETSI in this case. So these metrics must be additive, aggregable, and they are not difficult, but they need to be defined in these global perspectives. And these will be already a clear progress beyond 5G. Then we need intra-domain capabilities to meter with per flow, per service attribution so that we can realize what we are spending and where. So we need to include virtual entities and distributed entities to be able to measure these. And this would allow for 6G to have precise per service eco-accounting, both in energy expenditure and emissions. And these would enable this green orchestration and the runtime selection of suitable entities, more information also to the user in trying to potentially select a provider. And then we need inter-domain data exchange. So we need time and flow annotation between channels, protocols, and formats, and to have authoritative domains, verifiable and trustworthy. And these could be, again, a connection to ETSI, and also in the intra-domain capabilities when we're talking about this per session eco-accounting of energy and emissions, connection to 3GPP. So this is something that we will look for in the project. So
1 minute left.
Yeah. So we expect to have 6 key main results of the project. So behind the system, the incentive mechanisms, but also strongly contribute to standardization, as I explained. And we intend to try to demonstrate our results into test beds in Slovenia and Portugal. So we're very keen about impact. We will be interacting with target groups on all the value chain, trying to cover areas in energy efficiency and metering. And we're all about our team, and our team also covers the value chain of the telecommunications, including operators, SMEs, vendors, and research institutes. So that's it from EXIGENCE. Thank you so much.